This is the second video about the sequences. Here we'll talk about two things. First, some special sequences, and then we'll go for the geometry. Okay, if we take a look at the first sequence, this is 1, 3, 5, 7, and so on. The difference is 2 always. So you can think about this is a arithmetic sequence. You are right. But we still call them, this is like they are going to generate the odd numbers if you take a look here. The same thing is here. This is 2, 4, 6, 8. The difference is always 2. But this is, again, we call them the even numbers, right? So this is a sequence about the even numbers. And here is 1 square, 2 square, 3 square, 4 square. So this is the square numbers. And this is not arithmetic, because if you divide, this is 4, this is again something else, and so on. Okay, and here is the cubic numbers: 1 cube, 2 cube, 3 cube, 4 cube. So this is cubic numbers. Finally, here is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. If you remember, this is just prime numbers. So this is again not arithmetic sequence. What I'm having here is 1, 1. This is the sequence. 2, 3, 5, 8, 13. I'm thinking if it can be written as arithmetic, then I took the first difference. I see it's 0, then 1, then 1, then 2, then 3, 5. If I try the second difference again, I'll not have a regular difference, right? So this is not arithmetic. But I can just, if I take a look a little bit carefully, this is 1 plus 1. So 1 plus 1 give me 2. So this is, if I add them, I get 2 here. And if I add 1 and 2, I'll get 3. If I add 2 and 3, I'll get the 5. If I add 3 and 5, I'll get 8. So this is just un will be the addition of the two previous terms, which is un minus 1 plus un minus 2. Okay, or we call them an. Okay, it's an minus 1 plus an minus 2. So if you start, if you say, okay, a1 is equals to 1 and a2 equals 1, and you are going to start with n is greater than 2, so it's from 3. So if you say a3 here, for example, you will get a3 equal, if you substitute 3 here, then we'll get 3 minus 1, which is 2, and here is 1. So a1 plus a2, which is 1 plus 1, which will give you the 2 here. Okay. Here is just exercise. You should try it. This is nice, but maybe not the addition. Even if you add 1 plus 2, it's not 2, right? And if you add 2 plus 2, that's 4. But if you add 2 plus 4, is not 8. So try it. You may need to use another operation. Okay. One more sequence here is the sequence. This is just look like simple exercise for you if you understand everything's correctly. Okay, but I have fractions here. Okay, if I take a look, I could see here is sorry, I'm working here, sorry. This is 3, okay, this is 3, then 7, then 11, then 15, then 19, and so on. Okay, here it could be the difference is just 4, right? And if I take a look here in the numerator, the difference is just 3. So let me work on the numerator. The numerator, if I say an equals to a plus n minus 1 times d, a is equals to 3, okay, and n minus 1 here, and d equals to 4. So an, that is will be 4 times n, which is 4n, and this is negative 4 plus 3, which is negative 1. We'll go for the numerator. You can call it the n if you wish. Okay, the numerator. Then this is again, let's say a plus n minus 1 times d, but a here is 5, so that's 5 plus n minus 1 times d. The difference is always 3 here, so that's 3. So dn equals to 3n 3 times n minus 3 plus 5, that's plus 2. So the whole thing here is just 4n minus 1 over 3n plus 2. Okay, you may try this exercise. Okay, and the next question is, you are given such sequence, and we need to look at the behavior when n goes to infinity. So if I use, for example, large numbers, let's say a100, okay, that will be 100 minus 1, which is 99, over 101 here. Okay, and if you make it larger than this, let's say a 1000, then this is 999 over 1001. And if you go for 1 million, then I guess this is just 1 million minus 1, which is nothing, and 1 million 1, right? If you use the calculator, this is almost equals to 1. So what can we say is an, which is equal to n minus 1 over n plus 1, that is when n is very large, this goes to 1. I wish if you could also try this exercise, that if you have an equals 1 over n plus 1, see what will happen when n goes to infinity. N is very, very large number. Okay. The second part is the geometric sequence. The geometric is defined as, if you have a, then you multiply it by a ratio r, then you multiply it again by ratio r. So this is if you multiply by r, if you multiply by r, if you multiply by r, and so on. So the definition is, if you wish to find the ratio r, you just need to divide, okay, the second term over the first, ar over a, you get r, or you divide these two guys, ar squared over ar, and so on. So the ratio is just dividing, let's say, an over an minus 1. Okay, so the nth term over the previous term, and the nth term is very easy. You see, this is the first term. The second term, the power for r is just 1, and for the third term, the power is 2, and for the fourth term, the power is 3, right? Then for the nth term, we need a and that r, but the power n will be wrong. We need just to subtract 1 here. So this is the nth term. So the nth term is an equals to a times r to power n minus 1. Now, if we wish to use this formula, then we need to find. Okay, this is given for me. It's geometric. So we need to divide 8 over 3 by 4. Okay, that's 8 over 3 multiply. Okay, by 4 multiply 1 over 4. That is just equals to 2 over 3. So an will equals to a which is equals to 4 times r, which is 2 over 3, right, to power n minus 1. Okay, you can just write 2 to power 2 for the 4, and 2 to power n minus 1 over 3 to power n minus 1, and that is 2 to power n. Okay, that's 2 minus 1, which is just plus 1 here over 3 to power n minus 1. Okay. The second part, for the geometric, we need just to find the partial sum. We need to add we need to add all terms together. Okay, so if I try to add them, so this is my geometric sequence again, and I want to add them. So I want to add a1 plus ar squared till here. Okay, let me multiply this term by r. So if I multiply this term by r, I'll multiply a by r, so I'll get ar. Then I'll get, okay, I multiply this term, right? Then I multiply this term, I'll get ar squared. Okay, till the previous term here is ar n minus 2, and if I multiply it by r, I'll get a to power r n minus 1, and the last term is ar to power, that's n minus 1, and I'll multiply by r, so I get a to power r to power n. Now let me subtract Sn minus, okay, r Sn minus 1. So if I subtract ar minus ar, 0, That's why I arranged them in this way. AR squared minus AR squared is 0. This one will cancel. This one again will cancel here. So what's left is this, just the first term is A, and the last term minus AR to power n. Okay, and now we need just to take S in common factor here, which is 1 minus R equals to, we can take A common factor, which is 1 minus R to power n. Now you just need to divide by 1 minus R, 1 minus R, if R not equals to 1, of course. Okay, assuming R is not equals to 1. So that will be the general or the sum for the partial nth sum. So here is the formula, which is equals to A times 1 minus R to power n over 1 minus R. Now, here we need to find S4, for example. And this is, you can check, this is geometric because multiply by 3 and so on, or you have the general formula here. Okay, now okay, you need R equals to 15 over 5, as we said, this equals to 3, and A equals to the first term, which is equals to 5. So S4 equals to 4, that's the A here in the term, and 1 minus 3, okay, to power n, and we have n equals to 4, so that's to power 4 over 1 minus 3. Okay, you can work on this and get the answer. Okay, now when n goes to infinity, we need to find the nth partial sum here, right? And as you can see, if n goes to infinity and R is like half, let's say half here, okay, and you take it to power 100, for example, then this is 1 over 2 to power 100. So here is, this is very large number. So if you have, let's say, $1 divided by 1 million people or 1 billion people, then that's every guy will get around 0. So that's why this term will goes to 0 when n goes to infinity. So what is left is just A over 1 minus R. Okay, we need to find this sum. Okay, of course, if you don't know this notation, you need just to substitute 1 at the beginning, so you get 1 over 3. Then you get a plus, then you substitute the next term, which is n equal to 2. So you'll get here 1 over 3. So here will be 2, so 1 square, which is 1, and 3 square, which is 9. Then you substitute 3, so you get 1 over 27, and so on. This is geometric sequence. A equals to, or series is A equals to 1 over 3, R equals to 1 over 9 divided by 1 over 3, that is 1 over 9 multiplied by 3 over 1, which is just 1 over 3, right? And S infinity, you may write here if you wish, okay, or just S, that's A, which is 1 over 3 divided by 1 minus R, which is 1 over 3. Okay, so that's 1 over 3 is here, and here is 2 over 3, and that's 1 over 3 multiplied by 3 over 2, which is equals to half. Okay. This is the last thing here. We wish just to write this number as two fractions, okay, as a fraction of two integers. I could write this as 0.3454545, and so on. Okay, that's equals to 0.3 plus, okay, 0.04545, and so on, right? Okay, now that is can be written as 3 over 10 plus 45 over 1000, okay, plus 45 over 100,000, and so on. Okay, this is I can just consider it as geometric. A equals to 45 over 1000, and R equals to 4000 divided by or multiplied by 1000 over 45, which is equals to which is equals to 1 over 1000, 1 over 100, sorry, okay, because 1,000 and 1,000, so 1 over 100. Okay, so let me just find the sum of this. So that's S infinity equals to A over 1 minus R, and A equals to 45 over 1,000 over 1 minus 1 over 100. That is 45 over 1,000, and that is just 99 over 100, and that is just 45 over 1,000 multiplied by 100 over 99. That is 45 over 99, right? Okay, and finally what I need is, okay, you can also now divide by 3, simplify it. If you divide by 3, get 15, get 33, and so on. If I'm not wrong in my calculations, then the total thing is just 0.3, which is 3 over 10, plus this number 15 over 33. I'm a little bit, I'm not sure if this is right or wrong. You can just check again, okay? Thank you for watching, and see you in the next lecture.